welcome to MATLAB School. In this video, we are going to simulate the field-oriented control of induction motor. It's an indirect method. Let us get into the simulation part. So this is the model that we are going to simulate, and here we have the induction motor model. And this induction motor model is controlled through a inverter, through a three-phase inverter. The pulses are given from this FOC block. Here we have a battery with a ratings 400 volts as normal voltage. Rated capacity is 100 ampere hour. The initial SOC is taken as 50%. So since this being an induction motor, we need to give reference voltages for reference values for the flux. Okay, so here we have two things to be done. One is the ID reference, and here we have another one reference given to be given, that is called IQ reference, quadrature axis current and direct axis current. If you take PM as a motor, we will be giving 0 value for ID, and for IQ the value will be taken from the previous stage. In the sense, the actual speed will be compared with the reference speed, error is calculated, and the calculated error is manipulated by using PID controller. So here also we are doing the same thing, but the only difference that we have here is to calculate ID, we are using a slightly different technique from what we follow for PMSM. So here we have the flux reference to be given as input. So from the flux reference, we will be calculating the ID reference. So after calculating the ID reference, the ID value will be compared with the actual ID. So the actual ID will be calculated by this technique. So here we have ABC to DQ transformation. So this ABC is measured from the terminals of the motor. Then we have the theta calculation. So the theta is calculated based on this technique. So see, here we are calculating the rotor angle, and we are not measuring it directly from the rotor. So since we are calculating it indirectly, we are calling it as indirect FOC. Okay, right. So from the values of IBC, we are calculating ID and IQ. So these are actual direct axis current and quadrature axis currents. So this is the outer speed loop, and these two are the inner current loops. Okay, so this is the inner current loop which calculates the VD reference, and here we have the other current loop which calculates the value of VQ reference. Okay, so here we need to calculate a very important thing called the rotor angle. So this rotor angle is calculated from these calculations. Okay, so these are the formulas that we are using here. So yes, see, after calculating the values of direct axis voltage and direct quadrature axis voltage, also the theta, we are going for the next conversion, that is DQ, direct axis quadrature axis, to alpha beta frame. So from alpha beta frame, we'll be producing pulses based on SVPWM, space vector pulse width modulation. So this block is responsible for producing the pulses based on SVPWM. So let us try to run the model. Yes, the model is about to run. Yes, the simulation has started. So the gates will be coming from this block and it will be given to the inverter. So based on the pulses, the production of voltage and speed will be. So here we have yes. So here what we are doing here is we are uh, just trying to display the actual speed, the reference speed, and also the torque. Okay. So here we have a ramp kind of thing for the input. So this will reduce the initial torque drastically. See here we have given 10 Newton meter as the low torque, but what you can see here is uh, 20. Okay, the reason for that is, see, this is a very high inertia motor, so it demands more torque for the motor itself to run. Okay, so for that very reason we are getting a very high torque value at the output. See, even if you change the value to, say, for example 20, we can see the corresponding difference. Yes, so there is an offset of around 10 Newton meter. So as you can see, it is settling around 30 Newton meter. Okay. Yes, let us see the SOC of battery, also the current and voltages. So SOC is getting decreased. So this is the current and this is the voltage. If you want to see the current waveform, just type as scope. You connect a scope here. Just open it. Now we shall run the model. So this will give the value of the uh, phase currents. Yes. So here you can see the phase currents. If you want to see it, you can zoom it and you can see. Okay. So the same model is available for download from the link given in the description. If you want, you can download it and you can use it for your purpose. Please do like our channel, subscribe our channel, and please share our channel among your friends. Thanks for watching.